Welcome back to College Algebra. We are going to finish off section P8 in this video. I am Paul Walcher. Our first exercise we're going to look at is this decimal equation. It's not really a lot of new work here. I just wanted to do at least one that had decimal problems in it. There's really two approaches. You can clear the decimals first, or you can just work it as it sits. If you work it as it sits, just need to get all of your variable terms on one side, so I would subtract this 2.32x from both sides. So that would be negative 3.32x equals, move the 3.95 over, get negative 1.95, and then you'd have 1.95 over 3.32. And you could get an approximation in your calculator, or if you want to get an exact number out of that, you can actually clear decimals on a fraction by just multiplying by tens in sequence. You know, if you multiply by 10, it just moves the decimal one place to the right. So you can clear fractions as long as you move decimal points in tandem. Clear decimals off of fractions. So this is equal to 195 over 332. Which, let's see here. 195 is 5 times 39, which is 3 times 13. So the only hope of reducing is if 332 has 5, 3, or 13 in it. It certainly doesn't have 5. Numbers that are divisible by 5 end in a 5 or a 0. It doesn't have a 3 because to be divisible by 3, the numbers have to sum to something divisible by 3. And 3 plus 3 plus 2 is 8, not divisible by 3. 13? No idea. Let's see. 332 divided by 13. 13 goes into 33 twice, so that would be 26. 7, 2. I don't think it goes into 72 evenly. 5 times 13 is 65. So now, nope, it doesn't go in evenly, so that's as far as it will reduce. If you want to clear decimals at the beginning, basically do the same thing we did here. You just have to move the decimal point over. Tricky part is that, you know, this is 1.00x. So you just have to remember that. So this would become 395 minus 100x equals 232x plus 200. So move the 395 over, you get negative 195. Move the 232 over, you get negative 332x, and divide out the negative 332, you get 195 over 332 again. I think I rarely clear decimals when I'm solving problems. It just doesn't seem worth it, but if the decimals bother you, you're certainly welcome to do it. Now we're going to look at some general equations. General equations are basically formulas. They have a variable you have to solve for, but they also have several other variables. And the point is you are going to solve for one of those variables in terms of the other. So here we have WT equal RTH, and we are solving for R. Well, this is simple enough. If I just had 5D, or let's say 5 times 6 equal 7 times, R is the one I'm solving for, R times 7 times 8. Well, the way I would solve it was I'd just divide out the 7 times the 8. Because this is just a linear equation, I solve it just like, you know, R just has a power of 1. So I solve it like a linear equation. If I have my variable times a number, I just divide out that number. So my final answer is R equals WD over TH. Most of my students' response to that problem is, oh, that's it? Yeah. Problems aren't significantly more difficult than the other problems. You just have to recognize that they're still linear and that you have to solve them in the same way. This one is an even better example of that. We would solve it like any other rational equation. The first thing you do is you clear the fraction. There's only one denominator, so that's the common denominator. So multiply that into both sides. AX plus B equal 2CX plus 2D. Now, this is usually where my students lose their place. Remember, if we had 5x plus 2 equal 3x plus 7, the next step would be to get all of our variable terms on one side, all of our other terms on the opposite side. So for this problem, our variable terms that we care about are the terms that have x in it, because that's what we're solving for. So I'm going to get x on all my x terms on the same side. So I subtract that over. All my other terms on the other side, I'm going to move the b over. So I have ax minus 2cx equal 2d minus b. Let me do that. 5x minus 3x, 7 minus 2. The next step here would be to combine like terms. That's what I'm going to do here as well, but it won't look quite the same because I have these variables that I can't really combine. So what do? Well, we haven't talked about it in a while. We've just done the shortcut, but remember, the reason you can combine like terms is you can factor out the variable and then you can combine the numbers, because we have rules for combining 5 and 3. There isn't really a rule for combining 5x and 3x. It's just because you can factor, you can do this. Well, that means I can still do that part. Pull out the x, a minus 2c, and then I've in essence collected those terms, collected those like terms, so I can divide out this coefficient. Over a minus 2c. And that's the answer. So, same thing we would have done with numbers in all the places of a, b, c, and d. You clear the fraction. No big deal. Get all your variable terms on one side, all other terms on the opposite side. So all the terms with the variable you're solving for to one side, all the other terms to the opposite side. Combine like terms, even if that all you can do is the part of factoring out the common x, and then divide out its coefficient. Same as before, looks a little different, but it's the same process. And that's the end of P8 and Chapter P in general. It's a fairly long chapter because it really goes through all of a class in one chapter. All of intermediate algebra, which is a stuffed class anyway, in a single chapter. I think you'll probably like Chapter 1 a bit more, mainly because you'll have a little less homework to do. The homework drops off somewhat after, because I wanted you guys to really drill you in the foundations before we got to the actual college algebra material. Because if you don't get it now, it'll hurt all semester. So in the next video, we'll be looking at Chapter 1. We'll be starting off with the coordinate system, which may just be one video. It's a pretty short section. I think I can probably get through all of the theory and a few examples in a single video. I will talk to you then.